So now we're going to differentiate related functions. So this is probably the hardest part of related rates, is getting this derivative down. And the idea of taking the derivative in respect to t instead of respect to x. We're so used to taking the derivative in respect to x, and realize that d dx of x, the derivative of x in respect to x, just ends up being 1. So the x goes away. But do you remember how we would take d dx of y instead? Then we would write y prime or dy dx, and it wouldn't go away. And so many of you guys are like wondering what's going on here. Like if you're taking the derivative of y squared, then we bring down the 2, take away 1, but then we got to multiply by the derivative of the inside function, which would be dy dx, because in this case, the derivative of y is not 1, so we have to do the chain rule. It's still an inside function that we're going to take the derivative of it in respect to x. Well, now what we're going to do is we're going to be taking the derivative in respect to t. So if we take the derivative of x in respect to t, then it's dx dt, or x prime. Sometimes we kind of shorthand those x prime, y prime. But the idea there is it's not going away like it did before. Remember, dx dx just ended up being 1. It just went away. The x went away. Here it doesn't. It ends up being dx dt. And we would have to chain rule it as well, just like we did with that y. If you want d dt of x squared, you'd bring down that 2, take away 1 from the exponent, then times the derivative of the inside. So we still have to do those rules now. Now we're going to be doing it to both an x and a y. So let's go ahead and differentiate both sides on this one. So we have y equals the square root of x. So we're going to take the derivative of both sides in respect to t. I mean, you can see right here, it says find dy dt, right? And it gives us some given information. Remember, we learned in the past assignments about given information and what we need to find. So we're going to find dy dt. We're given x is 9, and we're given dx dt is 12. So going through this derivative, this left-hand side is just going to become dy dt, otherwise known as y prime, which is kind of nice that this one is, that's easy. It's already solved for. We're trying to find dy dt, so it's already on its own. Then we're going to still have to take the derivative of x squared of x, which is x to the 1/2. So that's going to become 1/2 x to the negative 1/2 times dx dt. Can't forget that chain rule. So remember, we brought down the 1/2, take away 1, and then keep the inside the same. That's what happened here. Then multiply by the derivative of the inside. So there's a chain rule that happened there. And then we put that on the bottom, and it becomes 1/2 square root of x times dx dt. Don't forget we have a dy dt on this side. And so dx dt is 12. So we're going to substitute that in right there. And x is 9, so that's going to go in right here. And now we just simplify. So that's 1/2 times 3 is 6. Well, 12 over that, which is 2. And that's the basic idea. So the big thing, remember doing that chain rule. We didn't have to do it on the y because there's no outside function. It's just y. So we didn't have to worry about it there. So here's going to be a little bit more interesting problem. So we're going to solve for dx dt this time. Y is -2. X is greater than 0. We'll figure out what they're talking about there in a little bit. So we have y squared equals x squared minus 5. I know I'm going to need to give myself a little bit more room. And so I'm going to take the derivative of each side. And so this becomes 2y times dy dx. or dy dt, excuse me, because we're taking the derivative in respect to time. Then this one becomes 2x dx dt. And then the derivative of 5 is just 0, so it goes away. So what are we solving for? We're solving for dx dt. So we're going to get dx dt by itself. And so I'm going to divide that 2x to the other side, multiplied by the reciprocal. Okay, so dx dt is by itself. You could do the substitution, then solve for dx dt, or you can solve for dx dt and then do the substitution. It's up to you. So now I'm going to go ahead and substitute what we know. So I know dy dt is 2.1, so that's going to go in right there. And then I also know that y is -2, so that will go right here. And then last, x, what is x? They didn't give us x, did they? They just gave us y, but they did give us an equation. So for x, we're going to use the y squared equals x squared minus 5, and we're going to plug in the -2 for our y and solve for x. Add the 5. Then what do we do here? We square root both sides, and when we square root both sides, that's where that plus or minus comes in at. So our answers are plus or minus 3. Well, this says that x is greater than 0, so we're going to have to go with the positive 3. So now we just multiply that, so that's -4.2 divided by 3. And that's the answer. I'll go ahead and give a detailed solution on this one. And so you can reference that in the notebook.